let's look at reactions that occur at a side chain in an aromatic compound. These will be reactions that involve these functional group conversions. A new reaction is the oxidation of an alkyl group to an acid group, as shown in this reaction here. So, when you see an aromatic compound or any organic compound, you will not panic, you will not freeze, but you will apply those organic chemistry skills, such as identifying structural features to determine the reaction type, and then using curved arrows to show how bonds break and form from a nucleophile to an electrophile. We will look at these 4 side chain reactions. The halogenation reaction is like this reaction. This is the allylic bromination reaction from Chem 12A involving the allylic carbon. The oxidation reaction involves the oxidation of any alkyl group with any number of carbons to an acid. The hydrogenation reaction involves an alkene to an alkane. We've seen that one before. And the elimination reaction converts an alkyl halide to an alkene. So here are a few examples of these arene side chain reactions. Take a look at these reactions and then stop the video and identify the reaction conditions for this reaction. So to convert the alkyl halide, which has a leaving group, to an alkene, that's an elimination reaction, so you'll need a strong base. So let's practice applying your organic chemistry skills. For each reaction, identify the product or describe a synthesis. For the first reaction, the hydrogenation occurs at the non-aromatic part of the molecule, and it will produce this product. For the second reaction, we want to replace an H at the benzylic carbon with an OH. So one way to do it is by this method. By using NBS in the first step, we'll get a Br substituted at the benzylic carbon, and then OH minus reacts at the benzylic carbon in the substitution reaction. For the third reaction, note that we're seeing a substitution at the benzylic carbon, but we're also seeing a carbon-carbon bond form because we're making a bigger chain. So that means we can either use a Grignard reaction or use the acetylide ion. So here's one way. That method is sort of long, so here's another way. The second method is just a little bit shorter. So here's another practice problem. Describe a synthesis to convert the reactant to the product. Stop the video. Note that the carbon side chain goes from 2 carbons to 4 carbons. That means we've got to form a carbon-carbon bond either by doing a Grignard reaction or using the acetylide ion. So here is a method to accomplish this conversion. So the first step is a substitution reaction in which we substitute the Br for the OH, and the second step is another substitution reaction in which the nucleophilic acetylide ion reacts at the alpha carbon in a substitution reaction, and that'll form our product.